So today we're going to talk about other key features of quadratic functions besides just the solutions. Today we're going to talk about the axis of symmetry, the vertex, and behavior, and whether a quadratic function graph opens up or down. The vertex of a quadratic function is that middle point that's like the highest or lowest point of the function. So we're going to say the highest or lowest point of the function. So if we look down here, we're going to skip down here, we're going to fill in the vertex now all the way across. So the vertex here, this is a high point. So we're going to say 7, 1 is the vertex. Here, the vertex is the low point, right there. In a table, it's not always quite as obvious. What we're going to do for a table, is we're going to look at the middle point of the function. And to find that middle point, we're going to connect y values that are the same. We're going to connect this 0 to this 0, and this -3 to that -3. And then whatever point is at the center of our rainbow, because this is like a rainbow over here, whatever point is left at the center, that's going to be the vertex. It's like the point that the function is symmetric around. So here we can connect 0 to 0. If we were going to connect this 15 to something, it would be 15 up here, but there's no 15 up there. So this is the point that's at the center of the rainbow. Now for an equation, we have two choices. We can either graph it. So in my calculator, I can say 2x squared plus 8x minus 3. And then I can't see my vertex. It looks like it's going to be way down here. So I'm going to say menu, window zoom. I'll zoom out, see if that gets it. Yep, okay. And then I'm going to say menu, analyze graph. Now because my vertex is the lowest point of the graph, I'm going to choose minimum. If it opened like this and it was the highest point of my graph, for example in this one, I would choose maximum. But this one is the minimum, so I'm going to hit enter. Start on the left, click, scroll to the right, click. And it looks like if I make it a little grabby hand there and then hold this button till it closes, then I can drag it so I can see it better. Click to drop it. My vertex is at -2, -11. So I can graph it. Or another way that you can find it if you don't have a calculator is you can do the opposite of b over 2a. Now in a function in standard form, that number is a, that number is b, that number is c. So the opposite of b is going to be -8 because b is a +8 over 2a, and a is 2. So you get -8 over 4, which is -2. That gives you the x-coordinate of the vertex. And then you plug that into the function to get the y that goes with it. And -2 squared is 4. 4 times 2 is 8. 8 times -2 is -16. Minus 3. So 8 minus 16 is -8. Minus 3 more is -11. So if you don't have a calculator, you can always use this formula to help you find the x-coordinate of the vertex. And then you can plug that in to get the y that goes with it. Or you can graph it and do menu, analyze graph, and then choose minimum or maximum. Either way it works. Now the axis of symmetry is an imaginary line drawn straight down through the vertex, dividing it into two symmetrical halves. So here, the axis of symmetry is going to go right down through there at the value x equals 7. If you look up here, or down here, I guess. Okay, this line right here, right up and down through the vertex at x equals 7. So the equation is going to be x equals 7. It's the x-coordinate of the vertex. Here, it would be x equals 1. Here's the x-coordinate of my vertex. So it'll be x equals -2. X equals 8. And then x equals -2. As far as minimum maximum goes, that's an I. If the vertex is the lowest point of the function, then it is a minimum. Oops. If it's the highest point, it is a maximum. So here, the vertex is the highest point, so we're going to call it maximum. Here, the vertex is the lowest point of the function. Down here, there's every part of the function is above it, so it's a minimum. Now for here, if this is our vertex and the y-coordinate is 1, is this the biggest y-coordinate or is this the smallest y-coordinate? -3, 0, 0, -3. All of these numbers are lower than 1, which means 1 is the highest, which means that that is a maximum. If you're not sure about that, you can always just roughly plot them. So you have -2, 1, and then you have -3, 0, -4, -3, -1, 0, 0, -3. And you can see that your vertex is a high point up there. Over here, -5 is smaller than all the other y-coordinates, which means that -5, the vertex is a minimum because it's lower than all the other points. Over here, we can tell just by looking at this equation if the function opens up or down based on this value of a. Positive a looks like that. Negative a looks like that. So because a is a +2, I know that this graph looks like that, which means that my vertex is a minimum. That's the smallest point of the function. The end behavior is exactly what it sounds like. How each end is behaving. Up or down. So here, these two ends are both going down. So we would write down, down, just like that. Or you can use arrows like that. If the function has a minimum, that means it's the lowest point and everything's going up from there. So the two ends are going up, up, or you can use arrows. Here, if the function has a maximum point, that means everything's going down around it. So down, down. Or you can write it with arrows. Here, this function, if this is a smallest point, we said that's the minimum, that means everything is going up around it. So that means the two ends are going up and up. Or you can use arrows. And over here, because A is positive, that means the vertex is a minimum and everything's going up on either end. So we have up, up again. And then lastly, if a function opens up or down, we're going to say that that is where the open part of the function is. So here, the open part of the function is going down. So that opens down. Here, the open part is up. So that opens up. Here, the end behavior is down, down. It's going down forever, which means the open part is down. Here, it's going to be going up, opens up. And then, because A is positive, we know it opens up. So it looks like that. Notice that whatever the end behavior is, that's also the opens up or down. Down, down, so this is down. Up, up, so that's up. Down, down, down. Up, 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 up. So that is everything you need to know about all of the other key features of a quadratic function. Now from here on out, we're just going to do a whole bunch of practicing.